Today we are going to present for Unit Operation Lab 2 with the course code CCB3062. Our topic of presentation today will be based on our last experiment, which is about sedimentation. We are from group A5 and our members are Kishortharen, me, Kliff, Yoong, Siang, and also Ching. We have chosen to study about water and wastewater industries, which apply the sedimentation process. So, why do we need wastewater treatment? Clean water is one of the basic needs for all living organisms. It is essential for health, hygiene, and the productivity of our community. But before that, what is wastewater? Wastewater is in fact defined as any water that has been adversely affected in quality. It contains mineral and organic particles, and therefore it has to be removed. With the wastewater treatment industries, it ensures a better quality of water supplies to be used industrially, domestically, or even for agricultural activities. Besides that, it reduces health issues that resulted from polluted water. The most common wastewater treatment method is sedimentation. Sedimentation is also known as settling, where it is a process of the removal of solid particles from a suspension by settling them under gravity. The solid particles or impurities are actually denser than water, but however, they are discrete. So in the wastewater industries, coagulants will normally be added so that these discrete impurities destabilize and form larger, heavier, and more settable particles. More detailed information regarding sedimentation process will be further discussed later in our presentation. Next, I'll move on to the customer's requirement. As mentioned just now, water is essential and widely used worldwide. Hence, clean water supply is important. This increases the market demand for wastewater treatment services. The water consumption has increased by threefold the amount over the last 50 years. This is due to firstly, the increment in world's population, secondly, the changes in lifestyle and eating habits, and lastly, the growth and development in water-using industries. Statistics shows that agriculture accounts for 70% of all water consumption, 20% for industrial users, and the remaining 10% for domestic users. In agriculture sector, water is used for irrigation of crops and pastures, stock, drinking water, dairy and piggery cleaning. As for industries, water is required for sanitation and cooling process. For example, the food industries. Water is important as it is present in almost all food. Water is used as both processing aid and cleaning purposes. Lastly, domestic water usage includes drinking, preparing food, bathing, washing clothes, and so on. Now I would like to invite Mr. Kishore for his part.
My name is Kishore, and today I'm going to talk about the process description of the wastewater treatment plant and also the process flow diagram. So today I'm going to talk about mainly 4 stages, which is the preliminary stages where water undergoes screening. The secondary step is called the primary stage where sedimentation occurs. And then we look at the secondary stage where aeration occurs. And finally, water undergoes the tertiary stage where disinfection occurs. As you all know, we are looking at the wastewater treatment plant. First, we look at the preliminary stages, where the water enters from different sources such as household and factory areas. Water is screened before going further to remove harmful substances such as aquatic animals, woods, plastic, and many more. This is to prevent wear and tear of the pumps. Next, we look at the grit removal where sand and stones are removed to prevent clogging from occurring. Lastly, the wastewater enters a storm retention tank, which is this to prevent flow equalization. Next, we look at the primary stages. Here, the organic solid material such as human waste is separated from the wastewater by the process called sedimentation. Sedimentation is a process where a larger and heavier object will sink at the bottom of the tank after a period of time with the help of gravity. At the bottom of the tank, the scraper will continuously scrape the floor of the tank and push the sludge away. The remaining water now moves to the secondary stage. Here water undergoes aeration. So what is aeration? Aeration is a process where air is passed through the water so that bacteria and protozoa could break down the tiny sludge that has been escaped from the previous process. At the same time, the sludge coagulates to each other to form a flock, and this flock will settle down eventually. Now, at last we reach to the tertiary stage. This is the final stage before exporting water to the external environment. To further improve the quality of water, the method disinfection is used to treat the wastewater. Disinfection is divided into three methods, namely chlorination, UV light, and also ozone. Chlorination is the most conventional method used because it's cheaper and also affordable, so therefore most companies use this method in order to treat their water. The second method, known as UV light method, is expensive because there's a high maintenance cost in order to replace the UV light when they are using it for a very long time. And then, besides that, UV light also provides a very good measurement to kill the unwanted bacteria. And lastly, we look at the last method, known as ozone. Ozone method is also same as UV light method because it's very expensive and also high to maintain. But therefore, the effect of cleaning is very, very good. So therefore, most of the companies will use the conventional method compared to the other two methods. Of the wastewater treatment plant. First, the water enters the preliminary stages. As you can see, the water enters the screening process where rocks or any other unwanted items are removed, and then goes to the grit removal tank where sands and rocks also are removed to prevent clogging, and then as it moves on to the storm retention tank where the flow is equalized. After that, it enters the primary stage where, as you can see, sedimentation occurs here with the help of gravity. After primary steps, we go to the secondary stage. Secondary stage where the aeration of water occurs, where the bacteria and protozoa will react to remove the unwanted sludge. After the secondary step, we enter the tertiary step. Tertiary step is the final step before the water is being exported away from the plant. So at the tertiary step, disinfection occurs. So disinfection is basically steps where chemicals are added such as chlorine to kill the bacteria so that the water can be provided, which is... So tertiary step is basically where chemicals are added such as chlorine to provide a pure drinking water. And finally, solids, the remaining solids and stones are handled and disposed through this process here, which will be explained by my other colleague.
Process flow diagram shown here. There are a variety of equipments that are required in the process of wastewater treatment. But for today, we'll be focusing more on the equipments that are related to the experiment that we have conducted. And these equipments include the primary settling, secondary clarifier, primary gravity thickening, and gravity belt thickening. How are these equipments related to our experiment is that all of these equipments are based on the concept of settling and sedimentation. The figure here shows one of the common types of sedimentation basin known as the circular sedimentation tank. And the function of each part of the sedimentation tank is further explained in the report. The most common form of sedimentation follows three steps: the pre-treatment process, flotation and skimming, and finally the settling and scraping. Firstly, the pre-treatment process involves the process of coagulation followed by flocculation process by the addition of reagents such as the polyelectrolytes and ferric sulfate. During coagulation, coagulants is added to clump the particles together as shown in the diagram below. On the other hand, during flocculation, the solution is mixed gently so that the small clumps formed during the coagulation process will gather together to form larger clumps. And these larger clumps will easily settle down and be separated. This pre-treatment process removes most of the sediment in the water. The next step is flotation and skimming. This process removes suspended matter such as oil which lays on top of the wastewater. What happens is that the air will be released at atmospheric pressure to adhere to suspended matter, causing it to float to the surface. The floated matter will then be removed by skimming device and then be transferred to a digester. Lastly is the settling and scraping process. There are three types of settling, which are discrete settling, zone settling, and compression settling. The discrete settling is a process that removes the discrete particles in a very low concentration without interference from nearby particles. In a suspension, as the concentration of particles increase, the particles will become so close that they no longer settle interferences from each other and the velocity of one another. The added number of particles in an enclosed area creates a slow-moving mixture, and this reduces the particle settling velocity. And it is known as the zone settling. The settling particles can contact each other and arise when approaching the floor of the sedimentation tank at very high particle concentration. So, in compression zone, the settled solids are compressed by gravity as the settled solids are compressed under the weight of overlying solids, and water will be squeezed out while the space gets smaller. Finally, the scrapers will drive the debris that settled under the sedimentation tank into primary gravity thickeners for further processing. So that's all for my part. Now I would like to pass to Mr. Kliff to explain on the results.
I'll be presenting about our results we obtained in our experiment. There are basically two parts to this experiment. In experiment A, we observed the settling rate for different heights, initial heights, and the concentrations of kaolin solution. Whereas in experiment B, we investigate the settling rate for different initial heights and concentrations as well, but with the addition of flocculants of different amounts. So firstly, 5 sets of kaolin solution are prepared with different concentrations as shown in the table and are filled into the cylinders. After that, we record the height of the clear liquid interface every 5 minutes intervals for 40 minutes. As we can see from the table here, the difference in height is extremely small. Next, we use these heights to calculate the settling rate. For example, to calculate the settling rate for particles in cylinder 1 at time interval 5 minutes, we use 90 cm minus the height at 5 minutes, which is 89.7 cm. Then we divide it by 5 minutes. That will be our settling rate. The following table will be the settling rate calculated using the formulas as mentioned just now. Okay, now let's analyze the first graph obtained. For this graph, we compare cylinders 2, 4, and 5, which has the same concentrations but different initial heights, 90 cm, 60 cm, and 30 cm respectively. The height of the clear liquid interface decreases with decreasing initial height. However, the height of the suspension does not affect either the rate of settling or the consistency of the sediment. As can be seen from the graph, the trend of the graphs for all the 3 cylinders are the same. The following graphs are for cylinder 1 and 2, which has the same initial height but different concentrations. Cylinder 1 consists of 12.5 grams of kaolin in 2 liters of water, whereas cylinder 2 contains 25 grams of kaolin in 2 liters of water. From the graph, we can see that when the concentration is higher, the settling rate is slower compared to those having lower concentration. This is because when the solution is having higher concentration, The molecules of the solution are located nearer to each other, which gives less space for the molecules to move into each other. Now moving on to experiment B. For experiment B, we investigate the settling rate for different volumes of flocculants added. The only difference in experiment B is that different amount of flocculants are added for the 5 cylinders as shown in this table. The same procedures as experiment A is taken to record the height of clear liquid interface, which is then used to calculate the settling rate. In this first graph for experiment B, comparisons for settling rate have been made between kaolin solution with flocculants and without flocculants. It can be seen that the height of the clear liquid interface for solution with flocculants is lower at different time intervals. This supports the theory. The function of flocculants is to bring together coagulated particles into larger aggregates and settle them. Flocculation occurs after the addition of chemical to destabilize the charges on the colloidal particles in suspension. These charged ions provide an opportunity for the charged particles in a system to adhere to them, thereby merging individual particles that are larger and heavier. Hence, the settling rate will be greater. Okay, so that's all for my part, and now I would like to invite Miss Lai Jia-fen for her part. Thank you.
Now I'm going to talk about safety. When it comes to safety, it's a personal matter that must be given top priority by everyone. Safety plays an important factor when dealing with any machinery or chemicals. In this case, a wastewater treatment plant may offer various occupational hazards. Hence, safety precautions must be taken, which includes operational safety, management safety, and design and built-in safety. For operational safety, workers are encouraged to wear securing straps before opening manholes for maintenance. Ensure that all electric cables are properly insulated, and also ensure that employees wear personal protective equipment such as safety glasses, face shield, dust mask, ear protection, safety helmet, and safety shoes. Moving on to management safety, all workers should undergo periodic examinations performed by occupational physicians to review early symptoms of possible chronic effects or allergies caused by biological agents. Besides, all workers should be provided with adequate training and be instructed before dealing with the plant. For design and built-in safety, a protective barrier should be built around the wastewater intake pumping station manholes. A proper lighting should be installed at treatment facilities to promote safer operation, efficiency, and security. Install handrails and guards around the tanks, stairwells, and other hazardous structures. Build in the chambers and structural ventilation channels to reduce the concentration of bioaerosols in the sewerage intake pumping station. And lastly, provide blower room with good ventilation. This is to avoid overheating. When dealing with wastewater treatment plants, the two most commonly used chemicals are chlorine and herbicides. Chlorine is used mainly for disinfection of the effluent, whereas herbicides is used for weed control. For dry chlorine, it should always be kept in a dry container with the cover sealed. This is to prevent moisture from coming into contact with the chlorine. It should also not be stored in an environment with electrical appliances, otherwise it will cause corrosion on electrical wiring and controls. For chlorine gas, chlorine cylinders must be stored in a proper enclosure to prevent unauthorized tampering with cylinders. Chain all cylinders to walls to prevent tipping. After changing the cylinders, check for gas leak by using ammonia bottle. Moving on to herbicides. Always make herbicides in a clean disposable container. It should be cleaned and disposed of unused portions and packaging materials properly. And never ever throw empty containers into lagoons or storage tanks. It's advisable to perform a hazard assessment. In wastewater treatment, one of the hazards is that germs are not fully removed during the process. As you can see here, this might be caused by partially blocked air filter, which results in reducing air pressure. Hence, filters should be cleaned regularly. Secondly, loss of composition. The filter might be damaged due to incorrectly installed, which causes failure of the system. Hence, there should be periodic maintenance taken as well as use a quality filter. Next, germs might not be removed properly. There is no flow due to blockage in sedimentation tank. This will cause no flow to the aeration tank. Action can be taken by introducing drain valve to collect the waste. And lastly, more pressure during the process caused by failure of compressor control, and therefore it will cause the tank to have higher pressure. To overcome this problem, alarm pressure should be installed to regulate the flow of pressure. And that's all from my part. And now I would like to invite the next speaker to present about economic analysis.
My colleague for a wonderful presentation just now. Hi, my name is Siang, and I'm going to present about the economic analysis. In general, costs are divided into three parts, which are capital cost, operation cost, and also maintenance cost. All of these costs must be included in account for the total cost of a typical water treatment plant. Capital costs involve long-term investment, which might involve fixed assets such as cost of equipment, installation, piping, instrumentation, and control. On the other hand, operation and maintenance costs are costs that must be paid continuously, which includes chemical substance, labor, machinery, equipment maintenance, and also electricity. According to Gunman, Kliff, and Hansen report about the total production cost of three example wastewater treatment plants, namely 5 mgd, 40 mgd, and also 130 mgd, conventional water treatment facility. As shown in the figure, the per unit cost for a facility is assumed to be operating at 70% capacity, which was calculated as $0.32 per 1,000 gallon for 5 mgd facility, $0.118 per 1,000 gallon for the 40 mgd facility, and $0.13 per 1,000 gallon for the 130 mgd facility. From the result obtained, it's proof that as the production output increases, the average total cost per unit of water produced decreases. Next, according to the case study done by Carly Sue Rogers on the McAllen Northwest facility, from all these processes as shown in the table, raw water intake has the largest cost segment, which is roughly around 37 million and accounts for 47% of the total cost. On the other hand, the least costly segment is sedimentation, which is roughly around 1.5 million and account for 2% of total cost. Another study done by McAllen Northwest facility is the separation of the operations and maintenance cost. For the McAllen Northwest facility, the largest contribution to the operation and maintenance cost item is the cost of moving raw water from one place to the facility by irrigation districts. Throughout the operation of the facility, McAllen utilities will spend roughly around 9.547 million for the expense of delivering the water, which account for 12% of total costs for the facility. Other than that, the cost items are energy, labor, and chemical costs, contributing roughly around 10%, 9%, and 7% respectively. The electricity costs depend on the capacity of the plant and the unit cost of energy. Hence, the capacity of the plant have significant effect on the operating and maintenance costs of a wastewater treatment plant. Wastewater came from household and industry need to undergo treatment process before it is released back to the nature. This is because wastewater might contain materials that will pollute the environment. Therefore, in wastewater treatment, there are 4 stages which the water need to undergo, namely preliminary stages, primary stage, secondary stage, and tertiary stage. As mentioned just now by my colleague, in preliminary stage, large particle will be removed, whereas in primary stage, sedimentation will occur where heavy particle will sink to the bottom of the tank. Sedimentation is the process of settling of heavier material in the water by the help of gravity. In secondary stage, bacteria will be added into the water to help digest the organic material in the water. Again, sedimentation happens here. After this, the water will undergo tertiary treatment where chemical will be added to ensure the quality of water is clean.